Hello students, today we will discuss method 4 in non-exact differential equation. So take one differential equation. Suppose number of terms in m is greater than number of terms in n. See here, number of terms in m are 1, 2 here, and here number of terms in n is 1. So number of terms in m is greater than number of terms in n. Then the integrating factor will be e power integration f of x dx, where f of x will be 1 by n of dou m by dou y minus dou n by dou x. See this m dx plus n dy equal to 0. First of all, check whether it is an exact or not. Take dou m by dou y. With respect to y means it is constant 0, and this derivative is minus 2 into 2y, that is minus 4y. Here with respect to x means 2y constant and x derivative is 1. So both are not equal. That's why which is an non-exact differential equation. And also we have number of terms in m are greater than number of terms in n. In this case, what is the integrating factor here? E power integration f of x dx, where f of x formula. Now 1 by n. What is n here? 2xy. Dou m by dou y minus dou n by dou x. Now minus 6y by 2xy is nothing but minus 3 by x. Now integrating factor is e power integration f of x into dx. Minus 3 integration 1 by x into dx is log mod x. Then minus 3 take as power, then e power log of any function is that function x power minus 3. Now multiply integrating factor to the given equation, then 1 by x cube into first term plus 1 by x cube into second term. After splitting these terms, x cube by x cube is 1, 2y square by x cube, similarly for the second term. Now it will be exact differential equation. So as usual, dou m1 by dou y equal to, with respect to y means this is constant 0, minus 2 by x cube is constant here, and y square derivative is 2y. Similarly, dou n1 by dou x is, with respect to x means 2y constant here, 1 by x square means minus 2 by x cube, because x power minus 2 form it is x power minus 2 plus 1, sorry, n into x power n minus 1. That's why x power minus 2 means minus 2 into x power minus 2 minus 1. So minus 2 by x cube here. So both values are equal means it is an exact differential equation. Now the solution is same as it is. Already we have discussed previously. Right, integration m1 into dx, where y as constant here and not having x terms. What are the x terms here? Here we have x terms, that's why not having x terms are not there. That's why we are taking as 0 here. And y as constant, integration 1 into dx is x here. Y constant means minus 2y square constant. X power minus 3 means x power minus 3 plus 1 by minus 3 plus 1. Now, which is the required solution for non-exact differential equation. Here also, number of terms in m are 1, 2, 3 here, and number of terms in n 1, 2. So 2 terms. So m is greater than n means number of terms in m is greater than number of terms in n. That's why first of all we need to check whether it is exact or not. Obviously, but with respect to y it is 1, it is 3x square by 3 and constant 0 here. And with respect to x means 1 by 4 here, y square by 4 constant, x derivative is 1. So which are not equal, in the sense it is non-exact and terms are greater. So integrating factor as usual formula. Now substitute in the formula. 1 by n means here n into dou m by dou y minus dou n by dou x. After simplification, 1 minus 1 by 4 is 3 by 4 here. 1 minus 1 by 4 is 3 by 4 into y square here. And take x common here, then 1 plus y square, and take 4 into numerator. Again 4 take as LCM, 3 common, 1 plus y square here. 1 plus y square gets cancelled, 4 gets cancelled, 3 by x will come for f of x. And integrating factor means e power integration 3 by x into dx. Now 3 into log x here, and 3 take as power, then e power log of function is x cube. So which is the integrating factor. Multiply the integrating factor to the given equation, then multiply for each term. Here also multiply for each term. Then which is an exact, which is also in the form of m1 dx plus n1 dy equal to 0. Find out dou m1 by dou y. With respect to y means x cube constant, y derivative is 1. With respect to y means x cube by 3 constant. This derivative is 3y square, 3 gets cancelled here, and this is constant whose derivative is 0. With respect to x means 4x cube by 4 is x cube, and y square by 4 constant and 4x cube, and 4 and 4 gets cancelled, x cube will come. So both are equal, which is an exact. So solution, substitute those values. Here y as constant means here y constant as it is, integration x cube means x power 4 by 4. Similarly, y cube by 3 constant here, x power 4 by 4. Here x power 6 by 6 into 2 here, and not having x terms means all are having x terms, so simply we can write 0 into dy. So simplify this, just multiply and take LCM 12, then 3 into this one and take the terms as it is. Take this 12 into this side, 12c is nothing but we can say C1. So see the next problem, it is also homogeneous, so we can also apply homogeneous, but it is also having that number of terms in M are greater than number of terms in n. Simply we can use this formula, which is non-exact first of all, and number of terms in m is greater than number of terms in n. So take the integrating factor, same formula, and 1 by n means here n, dou m by dou y minus plus 4y here by minus 2xy, then minus 2 by x will come, and minus 2 integration 1 by x into dx is log mod x, minus 2 take as power, then x power minus 2 will come, which is nothing but 1 by x square. Multiply with the given equation, then x square by x square is 1, y square by x square here. Similarly, x gets cancelled here. Now, which is the exact differential equation? To check this, find out dou m1 by dou y, which is nothing but constant derivative 0, y means 1 by x square constant into 2y by x square. Here, with respect to x means minus 2y constant as it is here, 1 by x is minus 1 by x square, minus into minus plus 1 by x square, both are same. So, which is an exact differential equation, and solution is same formula, integration m1, substitute m1 and n1. Here see here, not having x but here x term, so we should take 0 into dy here. And y constant means integration 1 into dx is x obviously, plus y square is constant here because y is constant, then 1 by x square, integration 1 by x square is minus 1 by x. So answer will be x minus y square by x equal to C here, which is the required solution. One more problem here, number of terms in M is greater than number of terms in N here. First of all, check whether it is an exact or not. Obviously, it is non-exact differential equation. Then also, we are using the formula for integrating factor where f of x value. So, 1 by n here, n means 2y, and dou m by dou y minus dou n by dou x here. Okay, and gets cancelled, it is 1. Integrating factor is e power integration f of x into dx, e power integration 1 means x here, and multiply with the given equation, then e power x into this, e power x into second term. Now multiply for each term here. Here also take the term as it is, which is in the form m1 dx plus n1 dy equal to 0. Now let us check dou m1 by dou y. What is dou m1 by dou y? Here with respect to y we are doing means x is constant, so whose derivative is 0 here. And with respect to y means e power x constant and y square derivative is 2y. Plus here total x term, so which is a constant whose derivative is 0. So plus 0. And dou n1 by dou x means with 2y is constant here, e power x derivative e power x. So both are same. Dou m1 by dou y equal to dou n1 by dou x. So which is an exact differential equation. So here integrating m1 into dx, n1, in this n1 all are having x terms, so it is 0 into dy, y constant, so it is like u into v, where we are using isolate formula here. Isolate means arithmetic we are taking as u here, and exponential we are taking v here, and the formula for u into v, integration u into v into dx is u integral v into dx minus integration u dash integral v into dx whole dx plus c. Already we discussed in the previous videos, and u into integration of v e power x integration minus u dash means 2x, derivative is 2x, integration of e power x into dx whole dx. This is the integration for this part, and integration y constant means y square constant as it is, integration of e power x is e power x here, plus again here u into v, this is u and this is v. So u into integration of e power x minus integration u dash 2x derivative is 2, integration e power x is e power x into dx whole dx. Now x square integration e power x is e power x minus 2, this integration is obviously e power x. Again we are taking what? U into V. Again u into integration of e power x is e power x minus integration u dash 2x derivative is 2 into integration e power x is again e power x into dx. Same term. And here also integration of e power x is e power x here, and this is what? 2 into integration e power x is e power x. Again 2 into integration e power x is 2 e power x plus c. So here after splitting, here also integration e power x is e power x, and take the remaining terms as it is, and 2 e power x minus 2 e power x gets cancelled. Here also gets cancelled. Remaining terms we are taking, which is the required solution. Here we have one more method, simply reverse of the previous method, that is number of terms in n is greater than number of terms in m. Simply instead of f of x we are writing here f of y into dy, where f of y is there 1 by n, here 1 by m, and there this minus this, here this minus this. So similar to previous method, but it is number of terms in n is greater than number of terms in m. Then the formula and integrating factor, see here number of terms in m are 2, here 1 2 3 terms, here it is greater than this, so we can apply this formula. Same dou m by dou y x which are not equal here, then which is non-exact now, and number of terms in n greater than number of terms in m here. So formulas, then substitute 1 by m means here m, dou n by dou x minus of this one, again this minus this 1 into, and 2 minus 1 is 1, and take x common here, y square plus 1 here, x y square plus 1, y common here, x y square plus 1. So gets cancelled 1 by y, again integrating factor with respect to y, log mod y, e power log of y is y, and multiply with y for equation 1, then multiply for each term here also, then which is an exact differential equation, dou m1 by dou y is, with respect to y means x constant, y power 4 means 4y cube, y square derivative is 2y, and with respect to x means 2y cube constant, here 2x, 2 2s are 4 into x into y cube here. With respect to x means 2y constant into 1 here, and with respect to x means y is constant whose derivative is 0. Now both are equal means which is an exact differential equation, obviously the solution. Here y constant means y power 4 constant, x integration is x square by 2, y square constant into 1 dx is x here, plus not having x terms. Not having x terms means here x, here x. So we should remove these two terms, and integration y power 5 is y power 6. 2 into here. So 2 into y power 6 by 6 here. Take 6 ACM, take it into this side, which is the required solution for given non-exact. Similarly here number of terms in m 1 2, number of terms in n 1 2 3. So which is greater than. So same method we can apply. First of all, obviously it is non-exact differential, dou m1 dou y and dou n by dou x here, which are not equal and also which is greater than, then formula, then simplification. 1 by m into, m means here m into dou n by dou x minus this one. Again this is 4x square, this is minus 6y, and here take common terms. What are the common terms here? Y. And when you are taking y as common, same term will come, gets cancelled, then 2 by y, e power integration 2 by y into dy is 2 into 1 by y integration is log y. Again 2 take it as power, then e power log of any function is that function here, and multiply the integrating factor to the given equation and multiply for each term here also, and then which is in the form like m1 dx plus n1 dy equal to 0. Again dou m1 by dou y. With respect to y we are doing means here x is constant, 2x square constant, and y cube derivative is 3y square, 3 2s are 6, x square, y square here, minus 3 into y power 4 means 4y cube, 4 3s are 12y cube. Similarly dou n1 by dou x is, with respect to x means 2y square constant, this is 3, 3 2s are 6, x square here, and y square constant here. With respect to y, total is constant whose derivative is 0, and here with respect to x means 12y cube constant and x derivative is 1. Both are equal, which is an exact differential equation, and the solution is same as previous one, and integration m1 substitute here, n1 substitute here. Here not having x term means we should remove this one and this one, only we are taking this part. And here y constant means 2y cube constant, and integration x square is x cube by 3 here, minus here constant here, and integration 1 into dx is x into plus. Here we have two terms as functions, so which is in the form u into v. Again we are using ILATE formula. ILATE, logarithm first, algebraic next. So logarithm function taken as u, algebraic taken as v. Take these terms as it is, and u into integration of y square minus derivative of this into integration of second part whole into dy. Now see here, this is y cube by 3, here y cube by 3. Next part. See, again here 1 by 3, take it as it is. Here y square, integration y square is y cube by 3, 3 3 is 9 here. Take the remaining terms as it is. Here also number of terms are in m is 2 and number of terms in n 4. So n is greater than m. So same formula up to here and substitute in m, dou n1 by dou n by dou x minus dou m by dou y. After cancellation we are getting 6x as common here. Then here also x common. Then same term will come here, only 6 common here, then same terms in numerator and denominator, then e power integration 6 into dy according to the formula, okay, then 6 into y here, then multiply this with given equation and multiply for each and every term for e power x 6y. See here, then again we are taking as m1 dx plus n1 dy. See here, dou m by dou y with respect to y means x constant here, and which is u into v form, means u dash means y square into v as it is, plus u into y square into v dash, e power 6y derivative is e power 6y into 6. See, and minus with respect to y means x square constant as it is, e power 6y derivative is 6 into e power 6y similarly. And similarly, and multiply this for two terms and take this term as it is. Now dou n1 by dou x is, with respect to x means y constant here, and x square derivative is 2x, 2 3 is 6 here, and with respect to x means y constant here 2x, and here also y constant, this is 3x square, and here total y terms so simply 0. Both are same means again we can use the formula for this. Again integration y constant means this total is constant and integration x is x square by 2, and y constant here and x cube by 3 integration, and this is what u into v method, again u into integration second term minus derivative of first term into second term integration into dy. Again y square and integration 6 e power ax means e power ax by a, that is by 6 here. Similarly y into e power 6y by 6 here. Again it is in the form u into v. Again we can take u integration of v minus integration of derivative of y means 1 into e power 6y by y here, 6 here. Again multiply for each term, then we are getting the solution. Similar problem, here same terms are there, right? Number of terms in m and n are equal. In that case, first of all we need to verify whether it is exact or not. Obviously it is non-exact, and verify for dou n1 by dou x minus dou m by dou y. So which is, this part is similar to first part or second part, let us check. When you are taking subtraction, what will happen? When you are taking subtraction, previous, numerator term is what? Minus 2. When you are taking common, this term will come. Which is near to first term or second term? Yes, it is near to m term. That's why we are taking the formula as 1 by m into. So 1 by m into dou n by dou x minus dou m by dou y. If it is similar to this part, then we are taking the formula for 1 by n into same formula, previous formula. Understood? Now take this cancel, then minus 2 by y, integrating factor formula, then apply the formula for same. Now see here, again m1, n1 same, dou m by dou y, dou n by dou x, which are equal. It must be equal because it is an exact differential equation. Then the solution, take y as constant here, not having x terms here. Similarly, you can do this problem as homework. I will give you a clue. 1, 2, 3, 4. Here also 1, 2, 3, 4. Same terms. So what we need to do is, first of all, dou m by dou y, dou n by dou y, they are not equal. And see here, it is like this into y dx function into x dy. It is of third method, but when you are taking the third method, what will come? Lengthy term will come. So it is not possible to calculate easily. That's why we are taking what? Dou m by dou y minus dou n by dou x. When you are subtracting, what will happen? One term will come in the numerator, which is similar to n or m. Let us check. It is similar to n. That's why we are taking 1 by n into this part. Then take cancellation. Then take the formula as it is. Now multiply with the given equation. Then it will become into exact differential equation, and do the solution as it is. Just do as homework. Okay.